All right, so today we're going to talk about Chapter 13, Day 6 notes, which is an introduction to partial fractions. There are two methods in order to do this. It's equating the coefficients, which we are going to try to eliminate any denominators and then set the numerators, parts of the numerators equal to each other. And then the second method is the convenient values method. So that one is where you try to get things to cancel out and get you 0, and that works in some problems, and it's easier to do one method over the other in certain problems. So we'll just take a look at which method looks better for which type of example problem. All right, so the first problem is number 1. We're actually going to do both methods. And so if you notice, the denominators are similar to one another. And your goal is to find a least common denominator, or LCD. So in any case, we always want to multiply by the LCD. All right, so what is the least common denominator in this scenario? Well, I need something that will cancel out all parts of the denominator. So if I multiply by 4x minus 3 and 4x plus 3, that will eliminate the entire denominator on the left side of the equation, and I'm just left with x. In the second fraction that I see here, the 4x plus 3 will cancel out with the 4x plus 3. That leaves me with a times 4x minus 3. And then when I look at the third part of the fraction here, I'm going to cancel out the 4x minus 3 with the 4x minus 3 there. So all I have left is b times 4x plus 3. All right, so method 1 is the equating the coefficient. So I need to distribute. I'm going to get 4ax minus 3a plus 4bx plus 3b. And I'm going to simplify by adding my like terms. So my x terms, I have 4a plus 4b. And for my constants, that's negative 3a and positive 3b. So I'm going to call that plus negative 3a plus 3b. So we are going to look at this coefficient and this coefficient being equal. And if this should be 1, then this should be 1. So I got 4a plus 4b should equal 1. And there's no constant on the left side, so this must be equal to 0. So I've got negative 3a plus 3b equals 0. All right, so at this point I want to solve a two variable system of equations, and I need to maybe multiply so that I can do elimination. So I'm going to multiply by 4 on the bottom and 3 on the top. And that should give me a 12 and a negative 12 to cancel out. So I've got 12a plus 12b equals 3. And I have negative 12a plus 12b equals 0. If I add together, I get 24b equals 3, which means that b is equal to 1/8. All right, if I were to substitute, I would get 4a plus 4 times 1/8 equals 1. So 4 times an eighth is a half. So if I subtract a half from each side, I get 4a equals 1/2. And if I divide by 4 on both sides, I get 1/8. So a and b are both equal to 1/8. All right, so we're going to do the same problem again using the other method. So this is the convenient values method. So we're going to look at this part right here, and we're going to pick up from right here. Remember, we've multiplied both sides by the LCD, and that gives us an equation that has no fractions. All right, so in order for this binomial to be 0, x would have to be 3/4. So we're going to say let x be equal to 3/4. And everywhere in the problem, I'm going to substitute in 3/4 for x. So I got 3/4 equals a times 4 times 3/4 minus 3 plus b times 4 times 3/4 plus 3. And this gives me a times 0, which is 0, so this cancels out. I have 3/4 equals This becomes 3b plus 3b, which is 6b. So 3/4 is equal to 6b. And when I divide by 6, I get 3/24, which is 1/8. Notice that this is the same answer that we got using method 1. All right, and then we're going to do same thing, but with something to eliminate this binomial. So what number could I put in for x if I put in negative 3/4? All right, so I'll do this up here. Let x equal negative 3/4, and that would give me negative 3/4 equals a times 4 times negative 3/4 minus 3 plus b times, if I put 4 times negative 3/4 plus 3, that gives me 0. So that would be b times 0, which is just 0. All right, and then if I were to simplify, I get negative 3/4 equals, 4's go away, I get negative 3a minus 3a, which is negative 6a. So negative 3/4 equals negative 6a. If you divide by negative 6, you get positive 1/8 again. All right, so we get the same answer for a and b, and we got the same answer using method 1 and method 2. So you can decide which method you like better, if it's equating coefficients or convenient values, and you can use it pretty much for any problem. All right, so let's look at question 2. So no matter which method you're going to use, you're going to first multiply by the LCD. So we look at all of our denominators. We've got a 6x minus 1, 6x minus 1 squared, and another 6x minus 1 squared. So that will be my LCD, which is 6x minus 1 quantity squared. All right, so I want to multiply by that so that I can eliminate all of my fractions. So my first fraction had 6x minus 1 squared in the denominator, which will cancel out. So all I have left is 30x minus 17. Then for this a fraction, one of the 6x minus 1s will cancel out, but one will be left. Okay, so I just have a times 6x minus 1. And then for this b fraction, the entire denominator will cancel out. So all I'm left with is b. All right, you could do the convenient values method by substituting in x to be 1/6, but I like the equating the coefficients method, so I'm going to do that. So I would get 6ax minus a plus b equals 30x minus 17. So I have x's and constants. So this is my x. And so 30 must be equivalent to 6a, which means that a is equal to 5. And then the other one would be negative 17 has to equal negative a plus b. And if a is 5, then negative 5 plus b equals negative 17, which is negative 12 equals b. So that's my final answer. All right, if you wanted to do the convenient values method, I would let x equal 1/6. That would eliminate the 6x minus 1. That would make that equal to 0. But then for the next step, you can just pick any value for x. Doesn't have to cancel anything out. You just pick any value that you want to substitute in for x, and then you'll be able to solve from there. So let's look at problem number 3. Remember, first thing you're going to do, no matter which method you select, you're going to multiply by the LCD, which in this case is x, and then x squared plus 2. All right, in this first fraction, the whole denominator will cancel out, so I'll be left with x minus 7. In the second one, the x's would cancel out, so I will be left with a times x squared plus 2. And in the third fraction, the binomial cancel out, but we're left with x times bx plus c. All right, so let's distribute. We have ax squared plus 2a plus bx squared plus cx. And then we need to look at what's on both sides of the equation. All right, for my x squared terms, I know that there is no x squareds on the left side, but on the right side we have an a plus a b. Right? So that has to be equal to the 0 x squared on the left side, so 0 has to equal a plus b. All right, for my linear terms, I have 1x equals cx, so c must be equal to 1, so that one was easy. And then if I look at the constant, that is equal to 2a equals -7, which means that a is equal to -7 over 2. And then I just need to go back and substitute -7 over 2 plus b equals 0. And so b is equal to +7 over 2. That's the end of that problem. All right, let's look at problem number 4. So again, first step would be, let's multiply by the LCD, which would be x squared plus 3 quantity squared. All right, in this first fraction, I'm going to get rid of the whole denominator, so it's x cubed plus 2x squared, and there's nothing to multiply it by. In the second fraction, I'm going to get rid of x squared plus 3, only one of them, so that means that one of those is left. That has to be multiplied by ax plus b. And then in the third one, the whole denominator cancels, and nothing is left at the top to be multiplied by the cx plus d. All right, so now I need to distribute. I will get ax to the third plus bx squared plus 3ax plus 3b plus cx plus d equals x cubed plus 2x squared. All right, so now I need to combine some like terms and compare my coefficients. All right, I have, this is the only x cubed, so I know that a has to be equal to 1. For my x squareds, I've got only 1, so that's 2 equals b. All right, for my x's, I've got 3a plus c. That equals no x's on the left side. I do know what a is, so 3 times 1 plus c has to equal 0, so c is equal to -3. And then for d and b, we have 3b plus d has to equal any constants on the left side, which is 0. All right, so now I'm going to substitute in 3 times 2 plus d equals 0, and d equals -6. And then I'm all done. All right, last question. All right, so we need to multiply by our LCD, which is going to be this binomial and this trinomial. So my LCD is x plus 2 times x squared minus 2x plus 4. All right, so in this first fraction, I'm going to eliminate both of these expressions. So the only thing that's left is 2x squared minus 11x minus 6. In my second fraction, I'm going to eliminate the x plus 2 part, but we still have a times this trinomial, x squared minus 2x plus 4. And in the third fraction, I will eliminate the trinomial, so I am left with the binomial, x plus 2 times bx plus c. All right, I need to do some distributing, so ax squared minus 2ax plus 4a plus bx squared plus 2bx plus cx plus 2c. All right, so I'm going to combine some like terms. I have a plus b is my coefficient of x squared. For my x's, I have a -2ax, a 2bx, and a cx. So I have plus -2a plus 2b plus cx. And then for my constants, I have 4a plus 2c. All right, now that should equal everything on the left side, which is 2x squared minus 11x minus 6. So now I need to set some of these coefficients equal to each other. So a plus b equals 2. -2a plus 2b plus c has to equal -11. And then 4a plus 2c has to equal -6. All right, so now for this one, we have 3 equations and 3 variables. And you could choose 2 different ways to solve this. So I'm going to say we have a system of equations. with 3 variables. So I'd say that most people are pretty good about solving systems that have 2 equations and 2 variables, but not when it comes to 3 equations and 3 variables. So I'm going to try to substitute first. We'll call that option number 1. All right, so in this option, I have A's and B's here, but A's and C's here, and I need to have both being the same thing. So if I could somehow simplify, maybe if I could make this equation have only A's and C's, if I could get rid of the B's. All right, so I'm going to solve for B in the top equation. I get B equals 2 minus A, and that needs to go in here. All right, so now I have negative 2A plus 2 times 2 minus A plus C equals negative 11. If I simplify that, I get negative 2A plus 4 minus 2A plus C equals negative 11. So I get negative 4A plus C equals negative 15. All right, and then I'm going to look at my equation that had 4A plus 2C equals negative 6. That came from the last equation. And if I were to add these two together, my negative 4A and positive 4A cancel out, and I get 3C equals negative 21, and C equals negative 7. All right, now that I know that, I can go back to the 4A plus 2C equation and substitute in C to be negative 7. So that's negative 14. If I add 14 to both sides, I get 8, and A equals 2. All right, so if I substitute in, the last thing is A plus B equals 2. I'm going to do 2 plus B equals 2, and then B equals 0. And now that I know A, B, and C, I'm all done. All right, for the second part, we're going to do a second option, which is using a matrix. So we are going to go to second and then x to the negative 1, which gets you to a matrix. We need to edit a matrix, and this matrix is going to have coefficients that relate to our system of equations that are found here. All right, so if you look at your coefficients, we have a plus b. That's 1a plus 1b plus no c's. And then on the other side of the equation is a 2. That's our constant. In the second equation, we have negative 2a, we have 2b, and we have 1c. And on the other side of the equation, I have a negative 11, which is my constant. On the third equation, I have 4a, no b's, 2 c's. And on the other side of the equation, I have a negative 6. That's my constant. So the command that you need to do is RREF, but you need to first input the matrix. So we're going to go to edit, and this is a 3-row by 4-column matrix. And we have our coefficients being 1, 1, 0, 2. And the second row is negative 2, 2, 1, and negative 11. And the third row is going to be 4, 0, 2, and negative 6. All right, and then once I inputted all the coefficients, I'm going to quit out of here. I'm going to go back to my main screen. I'm going to go back to the matrix menu, and this time I move over to math, and I need to find RREF, which is on the second screen. All right, and I need to choose matrix A, which is where I typed in my numbers. And you can close parentheses or not, it doesn't matter. This is your solution matrix. It has an identity matrix on one side. And then these are my solutions, 2, 0, and negative 7. So it's a way for your calculator to manipulate the matrix and solve your system of 3 equations and 3 variables without having to go through all of the work like we did in option 1. So you still get the same answers of A equaling 2, B B equaling 0, and C equaling -7. And that's just another way to do the problem. All right, and that ends the video for today, so have a nice day.